So we are moving on to Unit 8, Day 6. So we skipped over Day 5. It was just word problems with sequences and series. So we have 2 more lessons left. So Day 6 and Day 7 kind of could be a unit on their own. So we're going to start talking about limits. If you take calculus next year, limits is the first unit that we get to. So it is, I like teaching this in pre-cal so that you kind of get a feel for limits when we start in calculus. So we're going to be looking at limits through graphs and tables today, and then the next lesson you will be looking at limits algebraically. Okay, so what is a limit? So informal definition, if f of x, so in this picture f of x is just our graph, becomes arbitrarily close to a single real number L as x approaches c from either side, then the limit of f of x as x approaches c is L. So what in the world does that mean? So here's our graph f of x, okay? If we are looking at this x value c here, okay, this is our x value that I'm going to talk about. If we come in from the left side, so if we were to follow this graph in, we get closer and closer to the x value of c, well, we approach this L value, which is that y value there, okay? Well, let's say we decide to come in from the right. So you come in from the right, you get closer and closer to that x value of c. And as you get closer and closer, you're approaching that L value. So from the left and from the right, and we're going to learn more because this is continuous, you approach the exact same L value, which is the y value here. So a limit just says if you have come from left and right, whatever number you're approaching, that is going to be your limit. So the way this is written, and we looked at this with end behaviors before, so we will kind of tie back into that, but it's going to be the limit as x approaches c. So c is just whatever x value that they're asking you that it approaches, of f of x is just your graph or your equation, is equal to L, and L is going to be your y value, okay? So your answer to these problems should always be a y value. Okay, it's not very neat, but so it should be a y value. So the limit as x approaches some x value, c, of our graph is always equal to a y value, okay? This was coming from the left, this was coming in from the right. Okay, so we have to take a look at one-sided limits before we can actually look at a limit. So here's a graph they gave us. They did tell us what the piecewise function is, but we're not really looking at the actual algebraic part today, so you really just need the graph. So because this says, I'm going to write this up here, the limit as, and I'm looking at this first one here, the limit as x approaches 2, and it has that little minus sign at the top of f of x. That little minus sign there tells you from the left. So this means we want to find the limit as x approaches 2 from the left side. Okay, that's what that means. So we're going to come in from the left side. So the left is over here. And here's our x value that we're looking at too, so we can circle it so we can kind of see. As we come in from the left side, so you're coming in, coming in, coming in. The closer that you get to 2, you're getting to that y value of 2 here. So as you approach from the left and you get closer and closer to the x value of 2, well, you're actually approaching a y value of 2. So that would be your left side of the limit. Okay? So then for the limit as x approaches 2 with the plus sign, well, what do you think that plus sign means? Well, whenever you have this little plus here, this means we want to find the limit as x approaches 2, but this time we're going to be approaching from the right side of the graph. Okay, so change colors here. This time we are coming in from the right side. So we're coming in, we get to 2, and here we are at this point right here. So that y value is actually at 1. Okay, so we came in from the right side, and that graph at 2 was actually at 1. So the answer for that limit would be 1. Okay, so then it asks us, beside of this, or really under this. It says just the limit as x approaches to f of x. Okay, so this doesn't say left, this doesn't say right. This means the entire limit. So in order for you to do this entire limit, you actually have to do the left and the right. Sometimes it won't ask you to write those out, but you have to mentally think about them. So when we came in from the left, we were approaching 2. When we came in from the right, we were approaching 1. Well, in order for the limit to exist, it has to approach the same number from both sides. Well, this does not give us the same number, okay, because there's a jump in the graph here. So that means this is going to be does not exist, so we can represent that by D and E. And so you'll have a reason. Let me just write this out. The limit from the left and right must be the same. And we're also going to look at later, it has to be a real number, so it can't be infinity or negative infinity for the limit to exist. So from the left and the right, you have to approach the same number in order for this limit to exist for just 2. So because there was that jump in the graph, so we saw a jump in the graph here, and we'll kind of look at different reasons, but because we saw that jump in the graph, that's why that limit didn't exist. Okay, so next. Alright, so here's one example, but lots of different ways to write this example. So we are looking at, this is the graph of x cubed. Okay, so looking at the graph of x cubed, we have a graph here, we have a table here, and then we have the algebraic equation. So they want us to find the limit as x approaches 2 from the left of x cubed. And once again, x cubed is just the graph that we're looking at here. So I'm going to look at the graph first, and then I'll explain the table to you. So looking at the graph, we are looking at the number 2. So here's the number x value that we're looking at. And always kind of spot that out first. If you come in from the left side, so here from this left side, what y value are we getting closer and closer to? Well, it actually hits the y value at 8. So this is going to be equal to 8. Okay? And then it wants us to find the limit as x approaches 2 from the right. So we're going to be looking at the right side of the graph. So if we come in from the right side, so coming in here as we approach 2, well, we actually hit that same point, so it's also going to be 8. So that was the left, that was the right. Now, when they ask us here, well, what is just the limit, not the left or the right, but the entire limit? Well, because for the left and for the right we approached 8, that means that your limit, the answer, is going to be 8. So as long as these two numbers are the same thing, then you're going to be 8. We'll be looking at graphs a lot, but just in case you have a table. So if we were going to look at the table, these numbers are smaller, so this would be like coming in from the left side. And you see those numbers get closer and closer to 8. And then coming in, these numbers are bigger, so if you go from this side, it'll be coming in from the right. But you're still approaching the same thing. There's no jump in the graph here. This graph is continuous. Okay, remember when we talked about continuous on like day 2, or day 1 actually, but of the semester, you can't pick your finger up, so if you run your finger across this whole graph, you never have to pick your finger up, so it's continuous. Okay? So looking at example 2, so same kind of thing here. They give you the equation, they give you the graph, and they give you this table. So we're going to look at the limit as x approaches -1 of x squared minus 1 over x plus 1. Okay, and I'll explain the table at the end. So looking at the graph here, we're doing as we approach -1. So we're looking at this little area right here. So if we come in, it doesn't ask you for the left and the right, but I'm going to do the left and the right, so I'm going to write the left one first. If I come in from the left side, even though when you come in from the left there's a hole there, the y value that is approaching is still approaching -2. So it doesn't matter there's a hole there, you're still getting closer and closer and closer to that -2. So now let's do the right side. So like I said, they're not going to ask you the left and right always, but you always have to think about the left and right. You don't technically have to write them, but think about them in your head. So as you come in from the right, well, same scenario. There's still a hole here, but it's still approaching that -2 value. So when they ask you for just the limit as x approaches -1, because we've taken a look at the left and the right here, they both approach the same thing, so the answer to this is going to be -2. Now, there was a hole in the graph here. Hole is no big deal. You can have a hole in your graph and it can still have a limit. Okay, so far we've just seen when there's a jump, that's when you have to worry about it. So same kind of thing here. When you look at the table, if you come in from the left side, the numbers are still getting closer to -2. The reason it says doesn't exist is because that hole's there. But then when you look at the right as well, they're still getting closer and closer to that -2. Alright, so then if we take a look at example 3. So this time they're using a piecewise function. So really the piecewise function doesn't make a difference right now because we're just focusing on graphs today. So I'm going to look at the limit as x approaches -4 from the left first. So here's -4. Okay. So if I look at -4, if I come in from the left side here, the y value that it is approaching is 3. Now there is a hole there, but it doesn't matter if there's a hole there. And then if you look at the right side, as you come in from the right side, well, we're still approaching that same y value of 3. So when they ask you for the limit as x approaches -4 of f of x, because the left and the right were both 3, then the answer to this is going to be 3. Okay? So real quick, before I stop this video, I want to go back to a couple things. So looking at this problem right here, if I asked you, not thinking about limits at all, if I just ask you f of let's take a look at this other graph. Okay, I think I'm going to stop right there. I will talk about this, what I was about to talk about in the next video.